So yeah, welcome everybody to this RGI webinar of Pipes and Pylons. Is Europe planning energy infrastructure for a Paris-compatible future? And my name is Andrew Carey. I'm from RGI. A bit of a background about this this series that we've been running for NGOs specifically. We've been running it to provide civil society mainly with the information about the role of the grid in the energy transition. We've had 2 events so far. So the first event was really providing the basics of the role of the grid in the energy transition, how the energy transition is changing the role of the network operators, and how the network operators themselves can become facilitators of the energy transition. Our second event was focused more on digitalization. So it was looking at how the digitalization of the networks can help facilitate the growth of renewables, looking at different technology types. Yeah, so all the previous events are on our website, so you can check that out. This session, we're going to be focusing on energy infrastructure planning at the European level, so zooming way out, and how certain infrastructure projects are chosen and prioritized, digging deep into the TYNDP, which we'll get into a bit later, the scenarios behind the TYNDP or as part of the TYNDP. And what we want to do is really look at these scenarios and trying to understand to what extent they are compatible or not compatible with the Paris Agreement. And we're going to just have a little look. We're going to have great presentations from EEB and CAN, who will take you through some of the key issues. Regarding logistics, we want your questions. So there is a Q&A function in this webinar. So as the presentations roll, feel free to stick some questions that you have for the presenters in that box. And we will, after each presentation, we will have a scan of that box to see which of the most interesting questions that they can answer for you. We plan to go to 3 o'clock. The session will be recorded. Yeah, so and the presentations will be made available and the recording will be made available after the webinar on our website. And I'll send around a link to all participants. Okay. So yeah, the purpose of this session is for you all to get a high-level understanding of the European energy network planning process, specifically the TYNDP, see what the scenarios of the current planning process, TYNDP 2020, look like, and to understand if these scenarios can be considered compatible with the Paris Agreement. On a higher purpose, I would say the higher purpose of this webinar is to generally improve the knowledge, especially amongst NGOs and civil society groups, improve their knowledge and engagement with the European infrastructure planning process to help you, maybe in the future, ensure that it's aligned with the Paris Agreement. So the agenda, I'm going to give you a very brief introduction of what the TYNDPs are. Then we're going to go into the assumptions in the TYNDP 2020 scenarios and their Paris compatibility. That will be presented by Jörg Mühlenhoff from CAN Europe. After that, we'll have some questions. And then Jonathan Bonadio from EEB will take a deep dive on the gas question and the role of gas in the TYNDP 2020 scenarios, and having a critical eye on that. And then we'll have some time for 10 or 15-minute questions after the 2 presentations. So in terms of what the TYNDPs are, we've used the word infrastructure planning in a very broad sense for this webinar, but we're going to focus tightly on the TYNDPs. So these are the 10-year network development plans. They're produced by the NGOs, so the European Networks of Transmission System Operators, for electricity, E, and for gas. So these are the European bodies that represent the transmission system operators from the European countries in Brussels and at the European level. In 2009, these organizations were tasked with producing the 10-year network development plan. And what they do is they model a number of future energy scenarios to help determine and prioritize energy infrastructure development in Europe. The goal is to identify, well, it's done on a 2-year rolling process. So now we're on the TYNDP 2020. And then every 2 years, a new plan is produced. And the TYNDP works, it models a set of energy scenarios. So that's what we're going to get into today is the scenarios. To help understand the infrastructure needs for the future, what they do is they model scenarios following a number of different demand and supply, so looking into the future, how they develop. And the goal is to identify the cost-efficient solutions that optimize the interconnectivity of the European electricity and gas markets. So their main purpose, or previously the main purpose, has been on how to increase welfare, to ensure security of supply and reduce disruptions. But going into the future now, lots of this whole process is starting to focus a lot more on how to integrate such large amounts of renewables and to meet the energy and climate targets of the European Union. So they include energy transmission, electricity transmission lines, gas pipelines, LNG terminals, and also storage facilities are included in the plan. And the NSOs themselves, the last plan was produced by NSOE and NSOG together, and they coordinate, the NSOs act as a coordinating body, so they get all the information feeding in from the different countries, and they use that to produce the TYNDP. So in terms of its importance, the point of the TYNDP is really to inform the choosing of the projects of common interest, the PCIs. The PCIs are not chosen through the TYNDP, but it goes on to a separate process which is led by the European Commission. And these are essentially projects that gain the European stamp of approval and are considered of kind of continental importance. The PCI designation gives the project developers or the TSOs the access to the pot of cash in the Connecting Europe facility, and so they can take advantage of the money there. They also get fast-track permitting times and other advantages. In terms of where we are currently in the in terms of also why they are so important, just sorry, they act as a very important reference. So the TYNDP scenarios themselves and the TYNDP process is a very important reference, not just in terms of the official process, but they also act as the basis for lots of other studies that are done to understand the European grid and the European energy system in general. So as the scenarios as the basis for this process, making sure that they represent where we want to go in the future is very important. So in terms of where we are in the TYNDP 2020 process now, the scenarios have just been published. Well, they were published last year, and then there's just been a consultation which we've been replying to, and then going into the year they'll publish a separate. The NSOE and NSOG will publish separate TYND reports, and this ends up with the PCIs being chosen going into next year. If you see now, as I said, it's a rolling process. So this arrow, that blue arrow at the bottom, is actually the beginning of the TYNDP 2022 process, where they're actually now talking about the storylines, which are the precursors to the scenarios, and they set up the guide to how the scenarios themselves are built. So that's a bit of an overview of the TYNDP process itself, and how the scenarios. I mean, I think Jörg will talk a bit more about the scenarios themselves in the 2020 process. And in terms of where this work comes from, and some of the work that you're going to see being presented, is that this is part of the analysis that has been done has been part of the PAC project. So this is a project that's been set up between CAN Europe, EEB, RGI, and REN21. This project is all about creating a Paris Agreement compatible scenario for Europe. It comes mainly from EEB and CAN, so they're agreeing consensus within their networks, and it's with the three goals and with the three kind of guiding goals of producing a scenario that sees a 65% reduction in greenhouse gas emissions by 2030, net zero greenhouse gas emissions by 2040, and 100% renewables in Europe by 2040 in all sectors. So that's if you want to dig deeper more into the TYNDP process, Paris Agreement compatible scenarios in general. If you're newer to the subject, then please visit us on this website. Very finally, yeah, so I think we can hand over to Jörg now from CAN Europe, who will take us through the assumptions of the 2020 scenarios and talk about to see whether they are Paris compatible. So let me just pass over to Jörg.
Yeah, thank you very much, Andrew. I hope everyone can hear me well. I will just share my presentation now to guide you through the details of the 10-year network development plan scenarios. So my name is Jörg Mühlenhoff. I work as Energy Scenarios Policy Coordinator at CAN Europe. That's the Climate Action Network Europe. An umbrella organization based in Brussels with roughly 160 non-governmental organizations from the field of energy, climate, development, and also some think tanks are a member of our network. So we follow EU climate and energy politics, of course, and under the PAC project that Andrew just introduced, we are having a closer look on energy infrastructure planning, namely this acronym TYNDP that you just learned about. So I have been asked by Andrew to give an introduction about the content of the scenarios under the new TYNDP 2020, the draft storylines. That's how the grid operators, NSOE and NSOC, name their 3 scenarios. As Andrew explained, they are really quite important documents because they are lay the cornerstone for the development of further infrastructure for the investment needs. And they also, of course, are necessary to evaluate the applicants for those projects of common interest, the PCIs. So that's really about the money, of course, as Andrew just mentioned. So every 2 years, the grid operators develop this 10 years network development plan. Actually, it does not look until 2030, not only 10 years ahead, it's until 2040 and 2050. There are 3 draft storylines currently that are suggested by the grid operators, and we will now have a deep dive into the assumptions of these storylines, of these scenarios. The 3 storylines have different angles. First of all, to introduce the one you see on the left in these blocks, the national trends scenario is what the grid operators call a bottom-up scenario. They just collect first of all, the figures from their national members, from the national grid operators for electricity transmission grids and for gas transmission grids. And then they look how to comply with the 2030 EU targets. So this is kind of basic bottom-up or business as usual scenario. Which would lead to more or less roughly about 80% of greenhouse gas emissions reduction by 2050. So this is a trajectory of emissions reduction in this scenario that is, of course, not in line with the Paris Agreement, which requires us to stick to the 1.5 degree temperature increase threshold. So besides the national trends scenario, there are 2 more ambitious scenarios. The grid operators say that these scenarios would be in line with the Paris Agreement. We, as environmental NGOs, we have still some doubts about it. We criticized some of the assumptions and the way how they are designed in our feedback to the official consultation. So if you want to read more about our criticism, about the points where we think there is still some room for improvement, you can have a look into our feedback to the official NSOs consultation process that just ended in January. And on top of that, we also wrote a letter to the European Commission outlining the most important points where we think that European energy infrastructure planning needs to be improved. So the global ambition scenario, indeed, the name is telling it is a bit more ambitious than the national trends scenario. It has an angle that assumes more imports of different gases, fossil gases, non-fossil gases, so-called decarbonized gases. It is a scenario that is designed top-down by the grid operators themselves, like the third one, the distributed energy scenario, which puts a bigger focus on decentralized generation with renewables. But there is also the assumption that in the future we would have much more biomethane in the gas grids. So these are basically the big differences concerning these three scenarios under the current TYNDP 2020. I will now guide you through those scenarios by introducing two tables that first of all show the assumptions on fossil fuels in the three scenarios, and then on renewables in the three scenarios. And after that, in the end, we also expand a bit on the climate budget, a new approach that has been introduced by the grid operators that now allows them to say that their scenarios would be in line with the Paris Agreement with a 1.5-degree target. So what about fossil fuels in these three scenarios? We see that regarding the coal phase out, indeed the grid operators in all three scenarios, they see a reduction of coal consumption for electricity generation, for heat generation. There is even a clear coal phase out by 2040 in the global ambition scenario and in the distributed energy scenario. We as NGOs, as you might know, we are asking for a coal phase out by 2030 latest. And given the current market developments, it might really be possible that we see these coal capacities in many countries covered by ETS to disappear really earlier than 2040. So there's still quite some fossil fuels left, also regarding fossil oil use, in particular in the transport sector, that is pretty difficult to decarbonize. Then on fossil gas, my colleague Jonathan later will dig more into the details, but for sure all three scenarios expect still quite an important consumption of fossil gas. You can see that the distributed energy scenario says that there will be a fossil gas phase out by 2045, but this does not mean that Europe would not consume any fossil gas anymore. Fossil gas under this scenario would be converted to hydrogen, so-called blue hydrogen. That means fossil gas converted through steam methane reformation with a carbon capture and sequestration storage to hydrogen that could be produced within Europe or could be imported. These are the assumptions on fossil gases. Regarding nuclear power, all in all, the three scenarios see only a moderate reduction of nuclear. To illustrate briefly those assumptions and to compare them with what other scenarios say, I will now show a few graphs. There are, of course, more known, more present, visible scenarios like the European Commission's long-term strategy with its 1.5-degree scenarios. You see it as the orange graph. Top right, EC LTS 1.5 tech scenario. This is one of the well-known established scenarios that the EU Commission itself has developed. There is also the PRIMES model that shows what needs to be done to reach the current 2030 targets of the European Union. And when we look to the assumptions on coal generation capacities, indeed, the top-down scenarios developed by the grid operators under TYNDP 2020, but also the previous TYNDP from 2018, they were more critical with regards to the further development of coal capacities. So they anticipated coal phase out. However, still we, with our NGOs, Paris Agreement compatible PAC scenario, we assume that in the future, beyond 2030, maybe only only a few reserve capacities of coal power plants will be left, and our trend is a bit more ambitious with regards to coal phase out pace. Regarding fossil gas, let me briefly introduce, before Jonathan later takes over, let me briefly introduce the assumptions on gas demand. Total gas demand, including all fossil gases, biomethane, synthetic methane, as well as hydrogen, is pretty high according to all TYNDP scenarios that you see. You have here in light green on top the TYNDP 2020 global ambition scenario, which forecasts roughly 4,000 terawatt hours of gas demand in the year 2050. The previous TYNDP 2018 was more or less on the same level, as you can see with the orange graph. When you compare that with the European Commission's long-term strategy scenarios, you know, the 1.5 tech and 1.5 live scenarios, there you can see that the Commission assumes that we would consume much less gases to reach by 2050 net zero. For example, the EC LTS 1.5 live scenario foresees a bit more than 2,200 terawatt hours in 2050 of gas demand. So there are quite huge differences, and the Commission already made some remarks with regard to the big appetite for gases in these scenarios that have been put on the table by the electricity and by the gas grid operators. Finally, a short glimpse on nuclear power. We as NGOs in our draft Paris Agreement compatible scenario, broadly, we do not see any future for nuclear, except in some countries there will be a phase out of nuclear capacities, and the TYNDP scenarios also agree with that broadly, but still they assume that quite some nuclear capacities would have to be added during the next decades. The European Commission's own long-term strategy scenarios, they are even more optimistic with regard to building new nuclear capacities. Between 3 to 5 gigawatt of new nuclear capacities would need to be added every year. Just to make you aware of the fact that during the 2 last decades, the entire EU nuclear industry barely managed to accomplish this amount of newly added capacities. So there we have still quite some questions, and despite the fact that the TYNDP scenarios expect lower nuclear capacities, this does not seem to be very realistic at the moment. So just to sum up with fossil, I will jump quickly to assumptions on on renewable capacities. The assumptions on wind energy in the 3 TYNDP 2020 draft scenarios, they are between 540 to 629 plus 230 gigawatt of installed capacity for onshore and offshore wind. There is a dedicated installation assumed under the 2 top-down scenarios for hydrogen production, non-grid connected off-grid wind farms that only would produce electricity for hydrogen, which is not necessarily very realistic. We assume that those capacities rather would be grid connected. And when you compare it with assumptions from other studies, from other reports and models, when you look what the wind industry is saying, this is rather modest and not that ambitious. Just to compare with the current state of wind energy in the EU 28, we are currently at 205 gigawatt of installed capacity. So the scenarios expect to double, triple the installed capacities, while the wind industry alone for the offshore wind capacities, only on North Sea, Baltic Sea, Mediterranean Sea, Atlantic, they expect 450 gigawatt alone, offshore alone. without onshore wind capacities. So there are still some differences. Same applies to solar PV. We would say that shares of 10 to 17% of solar electricity by 2040, that is really not very ambitious. And given the learning curves, the steep decline in investment costs, this technology probably would cover more of our electricity demand in the future. On biomass, Jonathan will expand on that. Just to tell you again, here is a very big appetite for gas, for biomethane, not for raw biogas. We are currently in the EU at barely 200 terawatt hours of biogas produced. Only a little share of that is biomethane, is upgraded to biomethane. So from 200 terawatt hours, global ambition scenario would more than triple this amount, and distributed energy scenario would expect 5 times more biogas than we currently produce in the EU, which of course also puts the question of sustainability on the table. So we are quite skeptical with regard to that. To sum up this overview of the scenarios, we would say that the scenarios should go beyond just a mere assessment of pipes and pylons. There's much more to do, and this refers to the TYNDP also in a more general way. Infrastructure is more than just planning pipes and pylons. Our future energy system will have to be built around sun and wind, the cheapest in a decentralized way produced electricity. Around sun and wind, a number of flexibility options will have to be mobilized, meaning that whenever the sun is not shining and the wind is not blowing, of course, there has to be a kind of flexibility option. You can call it a backup. And this is, of course, first of all, this is the grid infrastructure that we have, electricity grids, gas grids. Grid extension is important, but that's not all. And if you look on grid extension, the current TYNDP modeling, the scenarios, they do not look on the distribution grid level, on the DSO level as such. On top of that, storage technologies would deserve a more in-depth assessment in those scenarios that we currently see. Mainly, there should be a cross-sectoral optimization of all these different storage technologies compared to flexible renewables, dispatchable renewables, who can provide ancillary services compared to the different energy infrastructure elements like gas grids, electricity grids, but also district heating that is, for example, not existing at all in the current scenarios. In the modeling, it's something that is missing, and we think that is really something where we need to make sure that the scenarios, the whole infrastructure planning would not become somehow flawed. Same applies to some extent to demand response. There is, however, a very good modeling of electric vehicles and their connection to the grid currently implied already by NSU-E, that for sure. So to finish my presentation, this first dive into the scenarios, still I was asked to explain the carbon budget, which is a more well, maybe a bit more nerdy or geeky thing to explain. I'm not a climate modeler, but of course you might have heard about the threshold of emissions that we should respect in order not to overshoot the 1.5 degree threshold. So scientists from IPCC, from the International Panel on Climate Change, they develop this approach to tell us how much carbon is left, how much can we emit still globally or on EU level, to make sure that we will not enter into climate catastrophe. The Paris Agreement, of course, confirms the 1.5 degree target. And when you try to break it down to calculate this on the EU level, then you end up with this figure that we would support, the 28.4 gigatons of CO2 equivalent as a carbon budget that is left for the EU 28 member states until the year 2100. This implies that the global emissions that still can be pumped into the air by mankind, that they need to be broken down to EU level. And we would not go for just calculating a per capita a number for the EU, saying like the EU, Europe has roughly 400 something million of inhabitants, so every European gets a certain amount of emissions. That would be too simplistic. We support the equity approach. That means that it is taken into account that Europeans have already emitted much more emissions, much more greenhouse gases in the past, in history. And when you factor in this historic aspect, and when you add on that Europe is one of the richest global regions that is able to immediately kickstart emissions reductions, then you would end up with this amount, which equals more or less 5% of the global emissions of the global carbon budget left. So 95% of the carbon budget remaining would be attributed, would be allocated to other global regions. So how does the TYNDP approach the carbon budget? They calculate just the emissions from the energy sector. They add the non-energy emissions, and we end up with roughly 80 gigatons of CO2 equivalent in the year 2050 already. So in order to reduce this amount, to stick to a carbon budget that is compatible with Paris, that is compatible with 1.5 degree threshold, they assume that carbon capture and storage and LULUCF, that is land use change and land use change from forests, for example, when you change the use of, for example, peatlands and wetlands to turn them into a carbon storage. These rather vague carbon removals account for quite an important reduction. The scenarios assume that we would get these removals, these carbon removals, already before 2050. And in order to stick to the carbon budget that the grid operators suggest in the current TYNDP, we would have to reduce further emissions beyond 2050. Yeah, this is like you emit already much more than the atmosphere can bear, and you have to reduce then again with further removals, with technologies that are not yet introduced, like bioenergy with CCS and with direct air capture. The carbon budget of 48.5 gigatons that the grid operators suggest is, of course, much higher than the 28.5 gigatons that the equity approach would bring about. This is because the grid operators allow themselves to go for another measurement of temperature, which would then lead to a higher amount of carbon budget left. And on top of that, they calculate the EU share by using the per capita approach. So every European gets an equal share, while we would say, of course, European citizens are not on equal footing like Indians or Africans when it comes to responsibility for climate change and combating it. So this is all in all a short introduction to a very technical and quite complex matter of carbon budget. As a takeaway, just let me resume. First of all, these emission reductions would come far too late, and the carbon budget is too high, and it's betting on getting technologies on the market that are not yet really available. Regarding the infrastructure planning, regarding the scenarios, of course, it's the job of the grid operators to make sure that infrastructure would not become a bottleneck for renewables, neither should energy infrastructure planning tie us to further dependency on fossil fuels and fossil fuel imports. So this is the kind of challenge we are at, and I'm happy to discuss now. I'm sorry for talking a bit longer.
Thank you very much, Jörg. Great. We have two questions concerning the carbon budget. One from Florian. I'm not sure if you can see that, Jörg. Maybe you can read it off yourself. It's in the chat box, relating to the base year calculation. I can read it out to you if you can't see it. So it's relating to
I see it.
Yeah.
Yeah, the question from the box is, I have a question regarding the proposed budget of 28.4 gigatons of CO2 equivalent. How did you calculate the EU remaining carbon budget? More specifically, the base year for calculation, considering historical emissions. Yeah, of course. That's the right question. We can dig a bit deeper into the carbon budget. I think we won't have that much time. You see here IPCC figure for global carbon budget in CO2 emissions only to stay below 2 degrees. Unfortunately, most of it has already been emitted between 1870 and 2011. That's the reference year that you were asking for, I think. This is still for 2 degree threshold, which of course is not what the Paris Agreement is asking for. It's much less left. It's the 420 gigatons of CO2 emissions. That would be the carbon budget left for the whole world, not only EU, that is the whole world, to stay below 1.5 degree. And if you translate it to CO2 equivalent, the scope of the 420 gigatons of CO2 is not complete, is too small. We need to consider not only carbon dioxide, but also other greenhouse gases like methane, like fluorinated gases and so on. Then you end up with 525 gigatons of CO2 equivalent for 1.5 degree threshold. And on this 525 gigatons, we applied other people, we did not do that on our own. This is one of the proposed methodologies to deduct the EU share is to go for the equity approach. Then you would end up with the 28.4 gigatons of CO2 equivalent that I showed in the previous slides. And the rest of the world would retain 95% of the carbon budget. That would allocate it to the rest of the world. So as I explained, the grid operators opted for another methodology, which is okay. But of course, you are not necessarily on the safe side. We are here with the 28.5 gigatons of CO2 equivalent with this carbon budget. For the EU 28, we would be on the safe side with a 66% probability of reaching this target. If you allow for more emissions, it could also work, but of course, we are arguing for a more ambitious and a more limited carbon budget in that regard. But there is no harmonized or agreed methodology on carbon budget as such.
Brilliant. I think we have time for one more question. A question from Robbie Morrison here. The role of final demand in the scenarios. He says, I am of the view that a sort of social transformation is key and that substantial energy sufficiency will be needed. Do you have any comments on that?
Yes, fully agree. Social transformation, it's a field that we have discussed, that we try to define also with regards to the assumptions we will make for our own Paris Agreement compatible scenario. You might know that since the beginning of last year, we organized a number of scenario workshops with members from other environmental NGOs, with experts, external experts and partners under the PAC project. And during these scenario workshops, we indeed discussed assumptions on things like social change, on behavioral changes, what assumptions, which energy efficiency gains can we expect. So this all will be available and accessible in our PAC scenario, in the final scenario.
Brilliant. Thank you very much, Jörg. I think it's time's pushing on, so we'll push on and see the presentation from Jonathan. I'll just give him the power. And Jonathan. Just to let you know, Jonathan, that your microphone is still on.
Yeah, can you hear me? Can you see what I'm displaying?
We can see you and your PowerPoint program rather than the, there we go, perfect.
Excellent.
Go ahead.
So, good afternoon, everyone. Thanks, Andrew. Thanks, Stuart, for this introduction. I think we are moving in a very nice way to the gas topics. So, I'm Jonathan Bonadio from the European Environmental Bureau. So, for those who are not familiar with the European Environmental Bureau, we are an umbrella association like CAN Europe with 160 members like CAN Europe, and we deal with a broad range of environmental topic, which means that we tackle both climate energy, but also overall chemical, agricultures, and other elements related to, for instance, biodiversity. And therefore, we can also have this broad view on environmental topics, and we'll see the role it can indeed play when it comes to gas and especially biogas. So I'm also working with RGI and CAN Europe on the PAC project, so Paris Agreement Compatible scenario, and I'm going to introduce a bit of focus on how the topic of gas is tackled in the proposed TYNDP scenarios, and how we can also raise questions and develop solutions in order to move away from a very high share of gas scenario. So before starting the presentation, a very first disclaimer, there will be a couple of figures in the presentation. There will be rough figures, estimates, order of magnitude. I mean, please do consider that some elements might have a slight margin of error. So I would require you to be very, I'm humble in the figures. So it's also some figures are here to illustrate. So in terms of comments, please consider this. Without further ado, I would like to start with a very broad picture, and with a picture which is actually not from me, not from the EEB, or for the PAC project, which is from Eurogas, a gas association based here in Brussels. So this is actually this picture. So I think it's a nice picture to look at. I think it's an interesting picture, and this is also the narrative that we constantly hear about gas. So I think there are two elements about the gas that we can see in this picture. First is the overall message, which is passed also by the gas industry, that gas, you see the word, is vital. So basically the fact that we cannot live without gas. And to a certain extent, currently in 2020, it's true. I mean, if you cut gas supply overnight, you might have issues. But why would you have issues? And why is gas so much currently associated with something comfortable, something we cannot afford not to have, something we need to have, and something we need for us and our comfort? Because gas in Europe is mostly at more than 80% used for one very simple thing, which is heating. And heating is key also to our comfort, to our security. So when you talk about gas, I mean, we shouldn't talk about gas molecule, gas generation, but also what we use gas for, which is heating. And it's also some elements which is currently missing from the TYNDP 2020, or which is a big picture of heating. Jörg discussed about district heating, discussed about renewable heating, discussed about heat pumps. There are a few elements, but I think this is the core elements in the industry. Also, the false claim that gas could be clean. I mean, we have also currently evidence, scientific evidence, that fossil gas is actually, in some cases, especially with the new fossil gas generation from shale gas, for instance, from other gas resources, including losses, including liquids, could be, in terms of greenhouse gas emissions, worse than coal. So why is the TYNDP, why is the industry, and why are also some of the general public opinion so much addicted to gas into energy? So here is the TYNDP scenario picture. I won't go into the details, so I just put a focus on what could be enabled as actually two most ambitious scenario, and you see that the amount of gas is like very slowly reducing, and we have to wait for 2030, 2035 to see a slight reduction in both distributed generation, distributed energy, and global ambition scenario that Europe presented you, which means that basically we are still addicted to gas. We pretend, we make the promise, we make the pledge that this gas would be whatever, renewable, green, decarbonized, so-called, but we are still addicted to this energy carrier in our in the TYNDP. And why are we so always talking about gas in these scenario? Because one of the narrative of the TYNDP is also that gas might be a transition fuel from coal. And for us, this is a very tricky message as a transition fuel. First, because what I said before about the greenhouse gas emission embedded into gas, it can have like up to 40% higher than coal. And I will forward you the sources for these figures afterwards. But also the fact that when you build a gas power plant, CCGT, it will stay in the landscape for 30 years. And this is a very basic assumption of a gas power plant for electricity, which means that when you replace coal by gas, you have to imagine, if you do it right now, you make the decision right now, you will wait for like 5 years to be finished. It will run until 2055. It's way too late. We are just putting the burden of the transition to the next generation when saying gas is a transition fuel. So this is also an important narrative we have to understand, and we have also to make a case for. Peak power flexibility. So it's also one element, and we will revert to this afterwards. I mean, it's true that if we go for electrification, we might witness high energy electricity demand in the future in terms of peak demand, but this is also neglecting what Jörg said before, which is all the remaining peak power flexibility. The electric vehicle is true, it's quite well modeled in the TYNDP, but demand-side alternative, demand-side flexibility for industry, for household, power to battery storage, but also power to heat, power to gas are also a bit absent. So in a nutshell, and this is the lesson of this first introduction, is yes, gas is easy. Gas is quite easy to use. We have the gas boilers, we have the gas network, we have the gas power plants. But the guarantee that the gas that we will use is not about 2050, it's about in 10 years or in 15 years would be fully fossil-free, non-fossil gas, or so-called green gas, is actually an assumption that lay questions in the TYNDP. So just for the very big picture, and I'm sorry for those who have high knowledge in energy. It might sound a bit redundant or a bit very easy, but some elements on these what it means in terms of sorry, this is a slip on my screen. Yeah, what it means in terms of gas consumption. Currently, what we consume as gas is around 450 billion cubic meters a year. It's like, just in terms of order of magnitude, it's 8 times the volume of the constantly gaseously. I mean, it's like 500,000 biogas units with the current output of biogas unit. It's 1 million onshore wind turbine if we want to replace it by hydrogen. So just to imagine what it means when we talk about decarbonizing gas, the amount of energy it means, the amount of generation units it means, and the amount of increase in our biomethane, in our so-called in a sustainable way, is also challenging. So just to have this in mind, when we are talking about decarbonizing gas, we're not talking about just decarbonizing like gas in industry. We are talking about decarbonizing a huge amount of energy. And the fact that if we can find the resource in a cost-effective, sustainable, secure way is also a question we can ask. So therefore, we have put our thinking in the analysis of some TYNDP assumption, and you can see that what the TYNDP has in terms of key assumptions for making this so-called green or decarbonized gas happen. These are actually assumptions that might be risky in the distant future. I mean, in terms of imports, we're going to import a lot of gas. So I just maybe a bit quicker because now I have 5 minutes less, but we're going to import a lot of gas. We have no guarantee that this gas would be fully zero carbons. And by remembering what happening with the sustainable biofuels, with imported biofuel, it's by experience in the EU lawmaking very difficult to make sure that an energy carrier coming from another continent would be fully decarbonized by just trusting some certificates, and this is very difficult. The greenhouse gas emission in the TYNDP, we assume that biosynthetic methane would be considered zero carbon in their life cycle, which is by definition impossible in terms of liquid production. I'm not saying they would be as GHG intensive as fossil gas, but we should consider the amount of remaining greenhouse gas emission from these energy carriers as well, even though labeled bio or synthetic. The CCS, as Jörg has put before, the carbon capture and storage, the TYNDP scenario rely a lot on these technologies to be available and to decarbonize gas. It's extremely difficult given the amount of CO2 that we need to capture, and given the current business model, given the current technology availability of CCS, carbon capture and storage. So in terms of hydrogen, I put it here. I mean, in terms of hydrogen, is that we also want to be fair in the assessment. There is an amount of renewable electricity for hydrogen only. We need to assess if it's feasible. We're not 100% sure yet. We are a bit more, might be a bit more conservative, but we know that hydrogen will be an important energy carrier, so we assume that might be a place and we should assess it. But this is another element also on the availability of landscape, on land, on the availability of resources for solar and wind generation, and how to allocate it in priority. So a focus on bioenergy, and I think this is important because, as Jörg has presented, we'll have the TYNDP relies on a huge amount of biogas, biomethane, so not biogas but biomethane in the future in order to decarbonize the gas supply. And here we can see that it's actually very, very also risky. In order for this to happen, all the 5 rows here that are presented in the table should be completely green light, which means that we should have 1/3 of the primary energy supply to come from biomass for 2050. It's almost doubling the current, not the share, but the current production, the supply. We have major concerns about sustainability, and think about the sustainability criteria for biofuels, what it means. Think about the conflict of use between energy and industry, when industry would need some carbon from bioresources in order to also decarbonize raw material and input from the industry. So there would be conflict of use. So the fact that we'll have amounts of biomass would be available is also very questionable. Considering greenhouse gas emission from biomethane from crops to be zero is also very, very optimistic, if not impossible, because of the overall ILUC question of, especially if you use maize, if you use dedicated crops, if you use even intercropping, sequential cropping, have carbon impact. So considering zero carbon is very, very difficult. The fact that currently we have to multiply the amount of biomethane, as I said, by 5, it's huge. In terms of resources, once again, the availability of resources is highly questionable. In terms of conversion, it also means that all the methane unit, all the biogas unit need to have a biomethane conversion. So they won't be able to burn biogas into combined heat and power anymore. And for instance, give it to district heating in one place and electricity. No, it should be 100% injection. It's true that injection is booming right now, but the business model of having 100% injection is also not easy and to be assessed. And also sequential crops, in order to feed this potential for biomethane, the TYNDP and through the Gas for Climate study from Navigant requires a lot of sequential crops. And for instance, we have currently sequential crops, but a very limited amount of crop areas, like around 3% they use for sequential crops right now. And the nature of sequential crops that are used in the TYNDP, so mostly maize, mostly high methanogen power crops, is actually excluded from a broad EU spread and the whole EU cropping and agriculture due to variation in climate. So the assumption regarding biomass that would be available for biogas production are, to our topic, also very risky to count on them. And last but not least, before I conclude, I think there is also a very important point here, we are moving towards circular economy. We have targets for reducing our food waste, for reducing our waste streams, for reducing our material consumption, for using and reusing the biomass, either for going back to agriculture, food, fodder, industry as a substitution for fossil raw material or fossil-based materials. In this context, it's also, we assume it's also very difficult to gamble of a multiplication by 5 of the available bioenergy sources. So, and we can also send you a couple of elements to support these this very broad statement. But since we're also in the PAC scenario, we are also solution oriented and trying to explain a bit how we can substitute, how we can have an alternative to this gas. There are options that you're presented, and I mean, energy efficiency. I didn't put sufficiency, but there was a question on sufficiency. I think sufficiency is very fair, it's very important as well. Electrification. So in transport, there's a big piece on electrician transport in TYNDP, it's true. All the services that could be delivered by renewables at distribution level. But I think there's something to summarize here. The alternative to gas is really about distribution level. So target the distribution level, what will happen in distribution level through aggregators, through district heating, and what will happen in the heat market. So to waste heat, district heating, on how to use heat. And with this element, and this also elements we are looking at in the PAC scenario, we believe that we can provide more sustainable and credible alternative to a continuation of overall gas use from any potential sources, and therefore also prevent lock-in by building infrastructure, by building power plants, or by simply selling gas boilers in 2030 when the gas is not still available. So voila, these are the overall questions, the overall statement that, and the overall analysis we made. We're of course happy to reply to these to the different questions, forward you any material, and we hope that it was helpful for you. So thanks indeed for your attention. I'm going to keep the slide with the two useful links. The one would be more the statements that have been made. So as Jörg claimed, our joint letter on the infrastructure, and the one on the what we are trying to build as a an alternative through the PAC scenario work. So thanks indeed for your attention. And now I'm going to switch and just check the different questions that have been raised, and also Andrew, I'm so happy if you want to moderate and raise the questions. Thanks.
Thank you very much, Jonathan. That was very interesting. I don't think there's any questions that have popped up regarding the gas question. I think it would be interesting if you could talk a bit about, which you do when you speak to NSOE, and you would like to say, how could you make the scenarios, or one of your scenarios, Paris compliant? If you could give maybe, and also to you, Jörg, just as a bit of a roundup before we end, your 3 kind of headline requests, or how do you think, what do they need to do to integrate true Paris compliance into at least one of their scenarios, and for it to be sustainable as well, especially talking about the gas question about sustainability. It would just be interesting to get those 3 headline points that you would like to say.
Yeah, okay. First of all, more variation from a scientific point of view. It would be good to have more different scenarios. All of them, as you have seen, are rather modest on renewables and pretty optimistic with regard to the further use of gaseous energy carriers. That's okay. You can calculate and estimate that. Why not? But then you should also run at least one scenario that assesses in a robust way how another world could look like. And the second point, all the technologies that we see now in the scenarios booming are technologies that have also quite some environmental footprints. I'm talking about CCS, where we are not yet sure whether this will really bring about a large-scale solution, whether this will be a long-term secure carbon removal. So the scenarios and the grid operators in their TYNDP, they should also consider what happens if those miracle solutions, I want to be a bit more provocative now, if these miracle solutions like CCS or direct air capture, if they won't be there in a few decades, then our recommendation would be look what are the most easy available technologies. What is the cheapest technology at the moment? That's renewables, that's solar and wind basically. Add a bit of biomass to balance it, and then harvest please demand side response, flexibility options that are there, make a proper assessment of storage technologies, and maybe then at the end we won't need all those pylons and pipes at all. Not, of course, we need them, but those that are planned and where public money is now spent for, they are at least a bit questionable. If you have followed the debates about the projects of common interest, the list that has just recently been voted in the parliament.
Thank you very much. We have a gas question here from James Dixon, aimed at you, Jonathan. What do you see setting the European wholesale price of natural gas in the coming decades if demand does in fact decrease considerably?
Well, it's a good point indeed. I mean, the question, I will be very honest with you, because in the PAC scenario, we so far are in the phase of modeling demand and supply and energy use. So we didn't reach the phase when we're gonna discuss prices and market. This being said, I mean, it's likely that if we see through either fuel switching at household level, through efficiency and sufficiency measures, I mean, we should see a rapid decrease in gas demand, but let's say the balance between the price of gas through higher carbon prices that we hope that we will see in the future, and the balance between this and the decrease of demand, I mean, it makes difficult to see what would be the overall price of wholesale gas in the future. But for retail, I mean, there is a point, and I think this is indeed an important point that you raised, which is about infrastructure cost. I mean, there is in the retail price, of course, a component which is made out of infrastructure cost and fixed cost, let's say. So if the number of consumers of gas decreases, if the number if the demand of individual consumer decrease as well, would it be cost effective and would it be competitive for the end consumer to keep a whole gas network and system running in a context of very little demand? And here, to be honest, very technically, I don't have the answer on how, for instance, to keep gas running for very hard to decarbonize sectors like industry or very niche elements, and then have just either phase out or just very slight backup for private households. So it's something we need to discuss, but which is sure, and that we will need to see how it happens. So I'm sorry not to reply very. I know I'm not replying fully to the wholesale cost, but the breakdown of the cost of gas and gas infrastructure in the context of decreasing demand is something we needed to look at.
Okay, thank you. I think we've got one last question that I think rounds it off nicely from Aliska. Sorry for the pronunciation. Is it possible to take part in TYNDP consultations as an environmental NGO? How do the consultations look like? Is it, for instance, similar to an environmental impact assessment? Jörg, do you want to take us through how NGOs can get involved?
Yes, of course. Thanks for this question. Indeed, Can Europe, together with EB, submitted feedback to the recent consultation that the grid operators run on those draft scenarios which I have just presented. So we, of course, discussed with our members internally what are the points that we would not agree with, or where we would have further questions, where we see room for improvement. We answered the public consultation. Even individual citizens could reply. It was a long list of questions, and via an online platform. There will be further consultations coming up on the final TYNDP 2020. There is a series of consultations that the grid operators are obliged to run to make sure that external stakeholder engagement is somehow integrated into their work. Of course, these consultations are not binding. The grid operators can take up some of those ideas or proposals, and they can also ignore some or reject them. The European regulator, ACER, European Agency for the Coordination of Energy Regulators, only gives a final advice just before the publication of the final report. So the grid operators are doing it on their own, more or less. And that's why it's really important and very welcome, in particular for environmental NGOs or other civil society stakeholders, to have their say. And if you want to participate in one of the next ones, in one of the next consultations, feel free to get in touch with us. We are happy to help out, to coordinate and make sure you can have your say.
Yeah, thanks, Jorgen. Thanks very much for that question. I think that's reached our time. I think we can wrap up. Thanks very much to Jorgen, Jonathan. Excellent presentations, giving a really nice overview. Just a reminder that if you want any more information on the TYNDP and the Paris compatibility of it and scenarios in general, please do visit our PAC scenarios website. You can also get in contact with us directly if you have any direct questions. And thanks as well to the Eclipse program, which has funded this series and all the help that they've given us. So I'm going to round it off, and I hope that you all have a very nice rest of the week. And thanks for logging on.
Thank you very much. Bye bye.
Thanks indeed. Bye, Andrew. Bye, everyone.